of machine learning. Now I would like to call upon Mr. Naveen Kaushik, IR, to welcome the speaker in the webinar. Naveen sir.
Thank you, Ayushi. A very good afternoon to all of you. Am I audible?
Yeah,
Yes,
we
sir,
can hear you.
audible.
Very good afternoon and welcome on behalf of MIT. I extend my hearty welcome to all the attendees and Mr. Vishal YADAV. He is again an alumnus of MIT Merit. As of now, I remember he was from 2015 pass out from the CS.
Yeah. Yep.
So Vishal, I extend my warm welcome to you. Today's topic is very interesting. That is keeping in pace with the fast-moving world of machine learning. These days, I also hear this name, machine learning, quite enough. And I hand over the control of this webinar to Mr. Vishal YADAV. He will discuss about this current topic for next 40 to 45 minutes. And you can raise your queries in chat box during the webinar, and your queries will be solved after this webinar, in the last of this webinar. Welcome, Mr. Vishal.
Thank you. First of all, can I ask, can you hear me properly?
Yes, Vishal.
Nice. Thank you for giving me this opportunity, I'll say, to give a talk about machine learning. First of all, I'll just start my timer so that I don't overshoot the time and everything is in control. So, okay, we have 45 minutes here and chat screen on. And let me share my screen. All right. Can you see my screen?
Yes.
Yes.
Perfect. That means yes. All right, guys. So let's start with the session. As I say, I'll try to keep it in 45 minutes, and then in last 15 minutes we can take the queries. So I'll quickly start with my introduction, really quick. So as Sir say, I did my BTech from computer science from MIT in 2011-15 batch. Then after completing my BTech, I got placed in Wipro Technologies and was working for Wipro for like a year as a .NET developer. And then after 1 year of being in Wipro, I decided to pursue my master's. So I went to United Kingdom and I did my master's in machine learning, data mining, and high performance computing, 16-17. And while being there, I was applying for several jobs and I got a graduate role. But the graduate roles are like there's a period of like 1 year between the finishing of the course and the start of the job. So I went back to India for 8 months and I actually taught in MIET 1 semester and I was teaching machine learning and pattern recognition. And after that, I joined Barclays, which is an investment bank in United Kingdom. In 2018, and I've been working there for like 2 years now. In fact, this week was I finished 2 years of the company, and yeah, it's been great. So let's move ahead to the topic. And also, yeah, I have been my job, because I joined as a graduate, so my profile has been quite mix and match in Barclays. So I've been working as data scientist for 2 years. For the first year, so I worked on a platform called Smart Investor. You guys can Google it, and it's a trading platform. So you can go on the Google, just like Barclays Smart Investor. So what people do, they can go and they can buy and sell their shares on that platform. And there's a trading team which manages online and offline orders of the shares coming. And my team basically designed application to support them. So my role is more for the first year because I wanted to do something in machine learning. So I pitched it to my manager and he was quite interested into that. So I've been doing some proof of concepts for the business where I tried to do, let's say, risk analysis, the recent project I did on data science was so so the platform generates some money for the business by taking a cut, a margin between for each transaction that happen over the platform. So I created a system where basically the model predicts using machine learning how much revenue the business is going to generate in this month, let's say in next 3 months or next 6 months, so that this gives a good overview to the business how to plan ahead, and they can tune things up and down based upon whatever foresight they are getting from that application. And because it's a mixed role, because my profile is technology analyst, so I jump between web development as well. So I do some Angular as well, which are like Angular and React, quite new into frameworks in web development. So I've been doing that as well. Yep. So let's start with AI, ML, and deep learning. Instead of just directly jumping into hardcore stuff, when I talked to Ayush, he said like the panel is going to be a mix of experienced people, non-experienced people, maybe student as well. So I'll try to tone it down. I'll not go in like really deep, really technical stuff. And I'll also introduce some of the stuff like definitions so that things are clear to everyone. So quickly jumping to definitions. You might have heard these terms a lot in recent time, AI, ML, and deep learning. It's quite a buzzword right now, and companies and people are jumping into it. So what is AI? AI is the capability of machine to imitate intelligent human behavior. So whatever we do and whatever we do using our brain, which is everything in our normal life, if a computer can imitate that, we'll say that's AI. But that's not necessarily is in machine learning. What distinguish between AI? Well, machine learning is a part of AI, but what distinguishes machine learning from AI is that machine learning is machine learning is not explicitly written intelligent computer. It's not this thing. So what is explicitly written intelligent computer program? So let's say I have a Rubik cube here. So if if I'm solving this, I know what algorithms to use and what steps I have to use to solve this Rubik cube from start to the end. But I can write a computer program for it, and it will have a lot of if and else. So it says like, okay, this color is here, this color is here. Okay, what steps I have to do to go to this step, then next step, and this next step. So this is like an intelligent behavior from the computer to solve a Rubik cube, or an example of playing chess. So there are like certain moves for the different different what's the word, like king, queen, pawns, horses, and whatever. So these things have different steps they take in chess. So we can program a computer how these are going to take a step while building a strategy to win the game. But this will again be more, it can be developed right in if and else rather than like a lot of if and else conditions. Like, okay, if this is there, these things are there, what else will you, what step you need to do. So, but these things are AI in general, but this is not machine learning. In machine learning, you need, you give a data and you give an algorithm, and algorithm just passes through the data and sees a pattern in it. So we don't explicitly tell it, okay, if this condition happens, then do this. It's the algorithm which automatically picks whatever you're trying to achieve. Like let's say we are doing a classification problem. We are giving two images to the computer and asking it like distinguish between a cat image or a dog image. Then it goes through all the images, picks the pattern, and just decides by itself whether it's a cat or a dog. An example, as I said, sorry, there are some questions. Okay, I'll take them later. And let's jump on to deep learning. So deep learning is a subfield of machine learning. It's very popular nowadays. So there are some types of machine learning. I'll go through it. So deep learning can do all of these as well. But deep learning are like certain sets of algorithms which are inspired by like how our brain functions. So they have neurons, and each neurons are connected using synapses. It's very biological. If you remember the diagrams from your 11th class biology lessons, So we had connections between axons and dendrites. It's very similar to that, but it became a base. It's not necessarily exactly how our brain works. Artificial intelligence, they just take inspiration from it, and they made algorithms later. And in recent times, deep learning has been the black horse, we say, in terms of machine learning and front runner, and it has been doing most of the AI related problems or solving AI related problems, and people have been jumping into that. There are a lot of hands up and queries, but as I said, like I'll try to finish first, and then I'll ask you what your issues are. And then these are the types of machine learning: supervised learning, unsupervised learning, reinforcement learning. So supervised learning is one of those which are very popular. Supervised learning means you have your data, and let's say, again, I'll give the same example. So I'm giving, let's say, 1,000 images to an algorithm, 500 of a dog, 500 of a cat, and asking the algorithm and training the algorithm to learn what is a cat, what is a dog. So it's very easy for us because we grew up watching cats and dogs, but it's not easy for computer to distinguish between a cat. And some dogs and cat breeds can look very similar to each other. So in supervised learning, we give the image, as well as for every image, we tell whether this is a cat or a dog. So we give a label. So when we have this label available with us, so these are called supervised learning. So because we are supervising the algorithm, we are telling it that you can use this information, which is already present with us, to make future predictions. And within this, we have classification problems and regression problems. Classifications are, as I saw, dog and cat. Regression can be, instead of classifying values into classes, you actually predict a value, and it can be a number. As I said, like I was doing in my job something called revenue prediction. So revenue will be a number. It's not a class. Once you get the revenue value, then you can, of course, classify whether it was a low revenue, did the business did good or didn't it. So that's regression. Other is unsupervised learning. That's very popular as well. And within that, clustering is, I think, most popular of all. Clustering is used for a lot of things, where you don't have label data, so that you don't have this prerequisite information you need to solve a problem. But with clustering, you can group people together. So a lot of the websites, especially e-commerce website and music streaming websites, they use this. We don't realize how common it is, but it's very, very, very common. Nearly every website is using nowadays. So a good example is your purchasing behavior or selling you the ads. So when you go on Amazon, you click on, let's say, a headphone. You didn't even buy it. You just clicked on a headphone. You saw, okay, I want to see this new Sony headphones, and you close the Amazon. You come next time, in the recommendation section, you see like 20 other headphones recommended to you, very similar to the headphones you had. So what they did, they actually grouped the product based upon their data together. So these kind of headphones, which have like kind of similar prices, similar looking, same company maybe, so they group them together. And when they have to push the information to the user, they just take that group and give the information to you. And it's just one of the examples. If you guys use Spotify or Ghana.com, sometimes you play a Ghana, and then based upon that song, they recommend you 10 or 20 more songs. And those songs are usually of the same mood, same tempo, same bass. So these things are very, they're everywhere, basically. Reinforcement learning, just skip it over for now. Reinforcement learning is learning by doing, just how we learn. A popular algorithm is genetic algorithms. They are very popular, but more machine learning, deep learning is towards supervised and unsupervised learning and towards clustering. Let's leave dimensionality reduction for now because we have really short period of time. All right. So coming to the specific deep learning part of machine learning.
Excuse me, Vishal,
Sorry, yeah.
You can extend your session beyond 45 minutes. There is no limit if you want.
All right. Okay.
No
yeah, but still, okay. Otherwise, it can also get boring if it's really long. So I'll still try to do it in like 40, 45 minutes.
as per your convenience. As
okay,
you wish.
okay. So okay, I can take like 5 or 10 extra minutes. So I can go through things which I'm skipping over. Like dimensionality reduction is, so this is a debatable topic right now. People used to say like dimensionality is a curse in machine learning. The more, so dimensionality is, I'll give you an example. Like if I want to predict let's say MIT is on Partapur place, right? So in Partapur, let's say if someone is predicting, they want to build a mall near MIT right now, and they figure out like this place is good, and they are going to predict like how many people are going to go into our mall, and seeing the location, they are going to take several factors into account, and these factors could be uh, okay, is it close to the highway or not? How many people already live nearby? What is the purchasing habit of the people who live nearby? How much money do they spend? And a lot of other things. So these features, which I told, do yes and no. Does it live? Does the mall will be closer to highway or not? Purchasing habits and things. These are features, and it's all one dimension when it comes to predicting something or solving a machine learning problem. So people used to say that more dimension you have, that means it's harder for the computer to solve, because each time we add new dimension, we add new feature, the complexity of the problem like develops exponentially. So people used to remove some of the dimensions so that we can save some computation power. But nowadays we have really powerful GPUs, and we can use cloud computing. So I personally use Google Colab and Amazon SageMaker. I do have a really good chip in my computer, a graphic card, but still it's quite cheap to use cloud services to train the model. And when I say it takes like really high computation power. So people used to think like it's good to reduce some dimensions, but now people also want to keep a lot of dimensions so that we have more features and a model understands better. Reinforcement learning, I said it's just learning by doing. It's just how we learn. Let's say learn riding a bike. So if you remember like how we started riding a cycle. So we first paddled for a while and we fell, and then we recall like, okay, this is not what we have to do. We have to put our handle like this. We have to pedal like this. We have to make our balance like this. It can't be slow. It can't be too fast. So we learn, like we practice. That's how reinforcement learning is. We give a actor and there is an environment. An actor do some job and environment skip the feedback. Sorry. So based upon the feedback, the actor changes its action next time and see whether whatever action it did this time was better from last time or not. There's some part of it like genetic AI, but that will be too deep to go into. Let's just jump into popular problems right now, and how. So till now it's been like more introduction to machine learning and what type of ML/AI. But now let's move to our topic, which for the today's session, which is like because machine learning is moving very fast. It's not like your normal other technologies are moving quick as well, like say web development. There are being a lot of frameworks and mobile app development, but machine learning is moving really quick. You have to keep up with it and to understand like how things are changing. So uh, let's talk about some popular problems. So these are very popular problems that people face in machine learning, which is image classification, object detection. So image classification, as I said, like classifying two images, whether it's a dog, cat, if you're classifying food items. And then there's object detection. So I give an image to the AI, and out of that image, the AI machine learning automatically picks like, this is a human, this is a car, this is a tree, this is a road. And it helps in a lot of areas, especially like self-driving cars, which are coming a lot now in market, like Tesla. So what they do is like they have a camera, and based upon the reading in the real time, they just can see whether the car going ahead of it is a car or a bike or a person. Based upon this, the car makes a decision whether to stop or dodge the person or the car ahead, something like that. And then there is another very popular field of machine learning right now called natural language processing. and within the natural language processing, we have these two very popular problems: machine translation, which is translating one language to another. Let's say English and German, Hindi to English. So we just write, you use Google Translation sometimes, and you just write like, okay, I write a sentence in Hindi and it should translate that for me in English. So that's a machine translation. It's quite handy. Everyone knows that. Next is language modeling. That's really, really, really popular right now. In fact, just before joining this session, I was actually watching a video. So there's like a really cool new algorithms which has been dropped 10 days ago. It's called GPT-3 by OpenAI, and OpenAI is a platform developed by Elon Musk, who is also the founder of SpaceX and Tesla. And GPT-3 is pretty cool. So what language modeling do is it predicts the next word. So for us, because we grew up learning certain languages, let's say we talk about Hindi, so Ram khana khata hai. If you're saying the simple Hindi sentence, we know how to frame this sentence because we learned it. And after khana, we know we usually put khata because because we have learned the language such that we can predict what's the next word which is going to be in a sentence. So language modeling is the same thing. We train an algorithm to predict what's the next word going to be if we give it any scenario. And it sounds very stupid, like why would you do that? But actually it can solve a lot of problems in language modeling and do some pretty cool stuff. Medical imaging, it's again image segmentation. Let's say I give a image of my chest X-ray, and based upon this, it can automatically detect like what are bones, where is tumor, where is my actually ligaments and tissues. So, and all these problems, there's like a like you, most of the guys will be joining MIT session, might be from academia. So what these academic people do, like they actually work on a standard problem, and they try to like when they do research, they work on the standard problem and try to beat the best results people have got on that standard problem so that they can write research paper. That's why there are some data sets which are very popular, like ImageNet, Food 101. I'll go through Food 101 more. Coco is very popular for object detection. English German translation is very popular for machine. So what we can actually make our own algorithms and see how we are doing for these data sets, how my algorithm is performing on these data sets, and then we can see like, okay, whether did we do a better job or not. And then yeah, I'll go through food 101 later. So what's ImageNet? Let's take just one image classification problem and one data set to just trim down the problem. So ImageNet is a data set made by, I forgot. ImageNet. Okay, whatever. I don't remember who made this data set, but it contains 40 million hand labeled images with 20,000 categories. It means that it has a lot of images basically, yeah. And 20,000 categories means like they are labeled. As I said, like in supervised learning, there are labels for images. So 20,000 categories means they have 20,000 types of items. Let's say they have images of crow, that will be one. They have images of, let's say, a hatchback car or a sedan or a SUV. So these are three different categories inside, in fact, for humans, and then for dogs, cats, so different things, mugs, anything you can think of, usually things. And then these are actually put into different categories. And there's a competition that happens every year called ISL VRC, and where a lot of companies participate, like Google, Facebook, individual people as well. And they try to beat the result from the last year. And so it doesn't contain all 14 million images, but it contains, all 20,000 categories. It just contains 1,000 classes. So it's like a subset of this data set, and people work on this subset and try to see like whoever did the best, whoever got the best results on this data sets basically wins that contest. There's some money involved, but it becomes a benchmark for the next year where people try to use the same algorithm and try to beat that algorithm. It's very popular in research right now. Then So this is the problem, which I wanted to talk today. So if you see, just for ImageNet competition, from 2011 to 2020, the algorithm's accuracy jumped from 50% to 90%. So let's say I started learning about machine learning in 2018, and uh, and within that time, there have been 9 different algorithms that have come, which are kind of like benchmark, which becomes industry standard every time they comes out. So we have to keep up. Like uh, uh, I have to keep up. If I started learning here next six, so I've been working on this algorithm. I'm trying to implement it and see whether I can improve it. Meanwhile, someone writes a new research paper, let's say after 6 months, a new algorithm that it automatically beats. And now I'm confused whether I should use this one, which I've been working on, or should I jump to this one because this is already better than what I've been doing. So this has been a big problem for machine learning. It's not a problem; it's a good thing because it's improving our everything right now related to machine learning. And it's just not this ImageNet. You'll see this graph happening like this for ImageNet. It's everywhere. Like every machine learning problem you take, it's happening right now. It's changing so fast that you have to keep up with it really, really quick. You have to read a lot of research papers. Uh, so this is I'm going to talk about for next 20 minutes and half an hour, like how you can keep up with it. So how do I know these things like ImageNet algorithms which are coming? From where do I get these graphs? So I'll say like I trust these three sources for me. One is Paper with Code, other one is Archive Sanity or Archive Sanity, depends upon how you say it. Some people say it Archive Sanity, and Twitter. So what's Paper with Code? Let me open my browser. Can you see my browser? I changed my application. I'll take a yes. Okay. So Paper with Code is a very popular website. It basically publishes all the new research paper coming in AI right now, but they have this button like browse state of an art. So state of art are algorithms which actually become the benchmark for people to use, like for any problem. So let's say I was talking about image classification. So in computer vision, image classification is a very big problem. Let's click on this. And within image classification, we have different data sets. People might have heard of MNIST, which is like a hello world of image classification. When I was teaching in MIETA, then of course I introduced students with this MNIST. But as I said, ImageNet is a problem. So you can actually go on each data set and see how algorithms have been working on this. So you can basically see every graph is like same. There's an upward trend. Some are like really steep, but some are flat, but you see the same trend. So depending upon what machine learning problem you are working on. So I give an example, like one of my ex-student, he just texted me yesterday. So he was working on a Snapchat filter. And in Snapchat filter, just like if you have used Snapchat filter or Instagram filters, like say the dog filter. So if you open your mouth to stick your tongue out, then a dog's ears come on your head and a tongue comes out as well. Same goes for pose estimation. So he wanted to make a yoga pose. So if someone is doing a yoga pose, then something happened, like some AR thing will happen. So how do computer know what pose the guy is making? That's again the computer vision. Image generation GAN, very popular. So people, you might have heard of deep fake, where computer can generate fake images. Same goes for natural language processing, medical. So whatever your field is, go on this website, go into state of an art, and go click on the problem you're working on, and then click on the data set you are working on. And sorry, yeah. Oops, I shouldn't have. And you can basically see what algorithms are being used right now and what is the state of an art. Then you can see like most of these algorithms come with code as well, so you don't have to write the code. So the best algorithm right now working for image classification on ImageNet is called uh, Fix Efficient Net L2, and it is giving a top one accuracy of 88.5%. And so you can click on the paper, or you can actually see the code as well. So let's see. Oops. Yeah. So it is from Facebook. So Facebook Research dropped this paper. So you can see like Facebook Research fixed threads. Let's go to their GitHub repo, and this is their code. And they just tell like how to use the code, how to install it, using the code, everything. And then you can just quickly run it and see whether it's working for you or not. So it will become a base for you to just continue your research or whatever project you are doing. It could be college project or something fancy application you are making. And this is the paper. You can actually go to the paper as well really quick and what they're talking about. Most of the people just shy away from the paper because it's like, oh, I can't understand. They have a lot of mathematics written here. This is not the normal language you speak in. But if you give it a little time, even I used to fear it a lot, but I've started reading them a bit lately, and I think you get a little comfortable with time over with them. So just give it a try. Otherwise, you can always find a summary of each paper on YouTube. There's always a guy 20-year-old in his room explaining papers, so you don't have to worry. Other one is Archive Sanity. It's not that well organized like Paper with Code, but it fulfills the purpose. And the third one was Twitter, as I said. Like, so I follow people who are like really prominent in machine learning on Twitter. Sorry, I miss where is my. So I follow people who are really good with machine learning on Twitter, and just they usually retweet if there's any cool thing happening in machine learning. So I'll say like Twitter is a really good medium for me at least, and you can try to do the same. Yeah, so Paper with Code, yeah. Let's so, but I gave you just these different platforms, Paper with Code and Archive Sanity, and you can read papers and see code. But how to set a goal, I'll say it's most important. So how you pick a problem and just because this within it's a very broad field. It sounds like a very certain field within computer science, AI, but within AI then there's machine learning, deep learning. But within deep learning, there's a lot happening right now. So you have to pick certain things for yourself to learn for. So I'll say pick a problem, stick to it. That's the motto I say to everyone. And so try to solve this problem for a really long time. And I'll go through a problem really quick right now, and uh, I'll tell you how you can stick to that problem and sorry, I got distracted by something on my screen. So you can stick to a problem, work on it, try to solve that problem for a really long time, and when it's solved, then move to the next problem. That's basically the advice which I give to everyone. I'll give you an example really quick about how what I did. Like recent time, I picked the project and what was my approach. So I think it will give you an idea of at least I'll not say like I'm a pro machine learning expert or something. I know a few things or two, but I'll say you can try the same process and see whether it works for you or not. And this will help you to exactly what's the topic of the meeting is to keep up with fast-paced world of machine learning. And I think I've been keeping up really well, at least for image classification. So I've been working on some latest algorithms in my free time. All right. So recently, so me and my flatmate, his name is Chris. He's from here, Edinburgh, Glasgow, and so we get along really well. So, but we love to cook food. We both really like cooking food and making tasty food. So what we decided, like we used to cook a lot, but we had this issue like he has he has expertise in cooking different food. I have expertise in cooking different food. So whenever we cook something really tasty, the other guys will say like, "Oh, man, how did you cook it? What's the recipe?" So some of the recipes, of course, we can find from the internet, but some of the recipes, like I know by myself, like how much salt to put, what spices to use. So we created a platform. We thought like we'll create an app where we can share recipes with each other. Now, so we created this app called Kitchen Shelf in our free time. It's still in beta version. It's going to release like this month. They'll keep it out. So it's basically a social network for sharing recipes. Like a recipe, share recipes with my friends, family. Can have close recipes. It's like Instagram, but instead of photographs, you see recipe. Sounds very weird, but to the foodie likes us, it works really well. Uh, And so he was working on making this app as a progressive web apps. Like you make the code, you write the code in Angular, like in WebDev, and it runs on every platform like Android and iOS and whatever. But these are the two main platforms, and you don't have to worry about writing the native code in Java or Swift. So uh, yeah, so but my part was like, okay, I'll do some machine learning in your app. So he said like, okay, when we go to the restaurant, uh, we really like some food. So what we can do is we can click the photograph of the food, and it basically automatically goes to any website where it can find the recipe and just bring that for you. So it's basically you're going to a restaurant, you eat something, you like it so much, but you don't know how to cook it. So you click a photograph of the food, and it should tell you how to cook it. That's the basic idea. So I needed to do image classification for it. So to solve this problem, I need to do like what kind of food it is. So first of all, my algorithm should know whether this is pulao or whether this is poha or this is biryani or whatever. So whatever food it is, so my algorithm has to know, but just by looking at the food, what it is. What I did, I started solving this problem because this is an image, again, image classification problem. My algorithm has to detect what food it is, but also, uh, yeah, it's image classification problem basically, but it's for a data set called Food 101. So instead of just taking random data, I needed to see whether the algorithms I'm using are good or not. So Food 101 is another one of those academic data sets. It has like 101 classes of food, and every class has like 1,000 images. So it's a pretty big data set. It's like 4 GB or 5 GB when you download it on your space. So I just wanted to see how the algorithms perform on that, and if it is working good on that, that will so I'll train my algorithm on that data, and whatever model I'll get, I'll use this in my uh, sorry, I'm losing my voice a bit. And beating EfficientNet before. So there are like a lot of algorithms that I tried on, but there was one which I really liked was starting in Inception, and there are some algorithms that we can use. But when I was writing this, I found one which is very popular. It's called EfficientNet, and this was like state of an art algorithm. It was designed by Google Brain Team. So I thought like, okay, why not give it a try? Let me run this and see how I'm getting the results. But this algorithm was designed by Google in let's say in one of the platform which I don't use. So there are like certain frameworks and platforms for doing machine learning. One is called TensorFlow. The other one is called PyTorch. TensorFlow is from Google. PyTorch is from Facebook. So I've been working on PyTorch for I'd say like 3-4 months. I wasn't most comfortable going back to TensorFlow, so I thought like, okay, I'll take this research paper, I'll write my own code, but I'll write it for machine learning using PyTorch. So what EfficientNet does is, okay, I'll skip this one because it gets a little more technical, because I don't want like to go and really dive into how this algorithm is working. But it's really up-to-date algorithm that works really good. So what I did, I tried to write the whole code in EfficientNet using one of the frameworks which I liked. I did that. I'll skip over these things as well. Basically, there are some 10 steps that you have to do: image augmentation, transfer learning. There are certain things that you need to use to make your algorithm better, but it's better if I skip over these. But basically, I was able to get the results that I wanted to get in that algorithm, and I was able to beat what Google was trying to do. So I use this platform, and I was able to beat the result, the state of an art result they're getting. I didn't publish this, but it was like at least it was close to the results. So I don't know if I'm So if you see 91.71%, so Google was getting 91.5%. I was able to get 91.7% on this food 101 data sets. And this became my base now. So I've used an algorithm which was developed by a company, which is already there in public domain. I use that. But now comes the wall in front of me. Now what should I do? How will I learn more? Because this is the latest algorithm. Either I have to wait for a new algorithm to come, which will come in like next 3 or 4 months, which will beat my record, sorry, this algorithm and give better accuracy, or I can start writing my own algorithm. So that's the second step that you have to do. As I said, like pick a problem, use an algorithm, stick to it, and once you feel like okay, you have reached that point where you don't need to go ahead anymore, then what you do is, sorry, you can't go ahead anymore. What you need to do is, then you have to try writing your algorithm. That's what I've been doing right now. So I found one algorithm which was written in 2017, which did some fancy work on the food. There's a thing called kernel. So I thought like I'll write my own algorithm. And writing your own algorithms can be tricky. It's need like really good understanding of some of the computer science fundamentals. So I thought like what will be the best way? So instead of just writing back in Python, I thought like I'll rather write it in some languages that I've never used before, like Swift and Haskell. So that's what I've been doing recently. I've been learning these these new languages, and based upon these new languages, I'll try to write my algorithms, and I'll learn these new languages as well. And I'll say like Swift is something which is picking up right now, because Python is not a really good language. People think Python is really good, but Python is a very slow language, and people are understanding it, and so people are starting to move a little bit away from Swift now. Python now, and moving towards other languages. So Julia and Swift, people are preferring them. It's a slight indication in the industry right now, not very popular. I might be wrong, but I think other languages are going to take over Python in terms of data science, because most of the data science work right now is done in Python. All right, so that's all right, and I think that's what I've been doing right now, writing my own algorithms in Swift and Haskell. So I'll say like pick a problem, solve it. It could be anything: making an app, writing a blog. Once you reach the latest algorithm, once you have used the algorithm, try to create your own algorithms, and try to blog or create videos about it. I do it quite often. I publish my things on Git so that people can actually interact with you. I am part of this Glasgow AI meetup where people do share their machine learning knowledge, and you can get feedback, and they can tell you like what's the best thing you can do right now. And I think that should be it. I skipped some of the stuff, but that's what very technical stuff, and I think I shouldn't go into the technical stuff a lot. It should be more a surface, like scratching the surface of machine learning for this intro. So I'll stop right now, and I'll give time to people to just ask questions, because I can see there are a lot of raising hands right now going on. So we can go to the questions, and I'll stop just 2 minutes before the session ends. I think I did good. Yeah, you can ask questions. And first of all, Ayush sir or Naveen sir, you can tell me whether you heard that. All right.
Well, the session was very good, Vishal. We have a question from Vishal ki Laila. That is, can you show famous?
Sorry, that's funny. Yeah, sir.
Somebody wrote it painting here. Is
Sorry?
it something related to machine learning? I'm just pinging you. You can check it out.
Yeah. Marilyn Monroe.
You can check it on the chat box.
Ah, okay. I think
somebody Vishal.
Yeah. So I think I get it what this guy is talking about. So when I was in my first year or something, this is funny. I like it. So when I first did something, I did a Photoshop of Vibhor, if you remember the guy. Vibhor.
Oh, this is Vibhor.
Yeah, yeah.
Okay,
So I
okay,
put
okay.
his face over Merlin Monroe face. I think it was, I
Okay.
think Sir Tripathi sir is also, he was asked, he
Yeah.
asked me to give a
We
session
have
on,
few more questions, Vishal. The
yeah,
very
go to
first
the machine
question
learning
is,
section. Yeah.
yeah, to machine learning, we have questions. Very first question is, how should one prepare for it towards industry perspective?
Okay, that's a
Uh,
good question.
this
So,
question, first discuss this and I will let you know other questions also. We have 3, 4 questions more on this.
all right. Okay. So I'll say like, it's it's hard to get into machine learning because most of the people who go into machine learning companies who prefer machine learning jobs, they want someone with PhD right now. I'll be honest with you because I've been trying to shift my job from this one to a research-based job, and it's a little harder because you want people who have spent some time doing PhD and research working to machine learning. But I'll say the best way is it's there should be something in your resume that should shine, and one of the way is doing a project. Just pick any project that could be related to machine learning. As I said, like I did started doing this food app, and we stumbled upon some of the machine learning ideas and we started doing this. So to prepare for it, just start doing some projects, and when you do the project, make them public, write them on GitHub, and when you apply for the job, you can actually show in your resume that I've done this project. In this project, do this. And if they are hiring for, let's say, natural language processing or collaborative reading or image classification, they'll see like your work, and even if you're a fresher, I think they can give you a chance. Yeah, so I'll say like do that.
Okay, fine. And now we have another question. How would one can filter industry-oriented stuffs as problem statement in research implementation?
How would one filter industry-oriented
Oriented stuffs.
stuffs as problem statement in research implementation? I didn't get it properly. So what exactly is the question? Can filter industry-oriented stuff as
Uh,
problem
do
statement?
we have
All
Dr.
right, all right. But I think the most of the research work you do anyway is industry-oriented. Like especially in computer science, it's not, I'll say it's not like biology or biology or chemistry, but most of the things goes on to industry. Let's say simple example of MNIST data set where when it was first done, it was designed to so the problem was someone was giving checks, and someone has to sit in the bank and see the numbers on the check every time, and see like what number it is and manually enter this in the keyboard. But now like there's a scanner which scans like what the person has written with his hand and picks the number from the handwriting, and so it was not it was research oriented, sorry, industry oriented, but it becomes a research implementation anyway, and it's now used like a standard benchmark for solving machine learning problems. So I'll say don't worry about mixing research implementation and industry oriented. Just do whatever you feel like doing. Anything, making any silly Snapchat filters to like hardcore quantum computer stuff. It should be all right.
Yeah, one question we have, is it possible for a teaching professional that is planning for a job transition to industry can be based on data science?
Yeah. Actually, industry love people from academics. As I said, like people, companies, they like people who have PhD, and most of the PhDs, most of the teachers usually have PhD. So if you are pursuing PhD, or if you have experience in data science, I think uh, it will be really, they give you preference. It's really good, especially in data science.
Okay. One question we have from the MIT student batch 2023,
Mhm.
that is there any difference between AI and ML?
That's what I said. Like, so ML is a sub part of AI. AI is like a big umbrella, and there is someone standing underneath it. That's machine learning. So AI has a lot of things. It's a big tree. I am not able to give a good analogy, good example, but basically, a machine learning is part of AI. So the only distinguish, I said, like AI has a lot of types, within which machine learning is one type, and AI can be something where any computer can show uh, any form of intelligence, but machine learning is specific, where we give algorithm and data interact with algorithms and gives a response.
Okay, okay. Then we have Dr. Jiten Sinha, a
Mhm.
neuroscience researcher.
Okay. Wow.
Uh, Is it possible for you to have a talk here itself with him?
What do you mean? Like he wants to talk?
One or two questions he has regarding something he needs to ask. So I'm promoting him to a
Yeah,
panelist.
he can
one more.
ask on the video or whatever he is comfortable with. If I have the answer, I'll give
I
you
am
for sure.
promoting Dr. Jiten Sinha sir. And in the meantime, you can have a talk with Prakhar Srivastav. I don't remember this guy, but he wrote something. Prakhar?
Hi Vishal, Prakhar this side.
Hi Prakhar.
So I'm 17 passed out from MIT itself, currently in Bangalore, Python backend development side. So one thing is like I really feel some days there's a lot of bubble going out in the market regarding the AI and ML stuff.
True.
Bubble stuff, I'll say like you know how the tech startup work and all the stuff going on in the market. So even see in the big companies what they are doing from the AI part is like only linear regression. Linear regression itself doing a lot of things on the market. So if you see the industry out of the site, sitting in your home and not going inside, not doing the PhD like you feel a lot of things are going on inside. But the reality somewhere something is like it's something different from what we think it is. And
sorry. So okay, I got the question. You are quite right, I'll say. But it's not that black and white. So there are a lot of companies who are trying to do some cool stuff as well. But I'll say like tradition. Even I face the same in my profession right now. Therefore, I was thinking like I'll change my job to some research-based job because. But I think the reason behind is because it's a very young technology compared to the others. So like when it comes to DevOps or some other standard things that we use in our industry, they have matured with time, and because they have matured with time, people understand them really well. You will not find a lot of machine learning expert because this is quite new in your team and in your workplace, and because of that. People can't get this broad idea of what could be used in the best way in the scenario that we have. So I say like it's quite mixed. It's not exactly like this, but you are kind of right to some extent. But I think I'm quite optimistic about it. You'll see a lot of people jumping to modern tech when they feel the pressure, because even the corporate is quite hyped up, right? So they do a lot of stuff which they see other companies are doing. So if someone is using Jenkins, for sure, so they'll use Jenkins. If someone is using some other tool, let's say Bitbucket for their code maintenance, so they'll use that. So I think when they'll see like, oh, this company is doing really good stuff in machine learning and they are getting really good results. Let's say they are doing some customer analysis and everything, and they could understand the customer generating more revenue. So they'll incorporate this well. But I agree with you that a lot of the companies, they are still sticking to the old ways and they are not keeping up, as I said, like with machine learning and it's very fast changing.
Right.
Yeah. Hi, Vishal. This is Jiten.
Hi, Jiten.
Yeah. Thanks for this wonderful session. It was really lovely. So my background is in neurosciences, but truthfully speaking, like I don't have much knowledge of, or you can say zero knowledge of AI. But I really get fascinated by the way AI solves the problem that our brain just thinks of. So,
yeah.
So I want, I am from the traditional neurosciences background, like neuroanatomy and all. So, I want to move to this machine learning and AI thing. So, what you would suggest, what things I or my
start with?
Yeah.
So, well, to be honest, being a neuroscience is a plus, because I remember when I was doing my master's, I had a module on neurosciences, just because they taught us just neuroscience, so that I don't know why it was part of the module, because it does fulfill some of the aspects right now, but you don't need to be. So I don't want to dishearten you, but it's just a little different. Like the concepts of synapses and activation functions, These are there, but they play a really small role in designing machine learning algorithms. It's more coding and mathematical side. But having said that, I'll say it's still very easy. And what plus you will have, what advantage you will have, is because you will see it from your other point of view, like from your own field point of view, when you see the machine learning problem. So maybe you'll be able to design some new algorithms. The base, I'll say, to start with is I really like to start with a really quick online course, just Coursera, like, yeah, very small course. I'll not say like go on like a really one, and just pick a project and do a project which is related to your field. Let's say in neurosciences only, and it might be not, you should not be thinking like, okay, I'm trying to use neuroscience in a different way than the traditional way machine learning is being used. You can solve a problem in neurosciences, not designing an algorithm to start with, and then slowly move towards like the bigger picture. But yeah, I think it will be really cool for you to jump into machine learning, because I'll say like still 20% of the deep learning is related to neurosciences.
Yeah. Thanks, Vishal.
No worries. Cheers.
Vishal, one more question. Can you please share the site where we can have the data available on which we can work with the machine learning algorithms?
So the problem with data, it depends upon what problem you are going for, but you can find most of the data on this platform called Kaggle, and I highly recommend. So this also answered Jitain as well. So I think after it's a good someone asked this. So after, like, if you have done like a quick course, I'll say like start doing competitive programming. So people recommend this a lot, right? And in competitive programming, there's like problems which come, like these are all machine learning problems, and there's like money related to as well. If you win this, you get like $55,000 and everything. So these come with data sets. So you can try solving these problems, see other people's solutions and everything. So they share their notebooks as well. So you learn a lot from here, and you can go to the data section and get the data sets. It's very popular. Like if very popular is like COVID-19 patient precondition data sets. If you want to work on something really new, so you can use machine learning to detect COVID-19 in someone or not. So you can work on these data sets and something like that. So it's very popular. Go on this platform, Kaggle, or I think Google Scholar is all right, but most of the thing you just Google, just Google it, whatever you want to work on. Just write, okay, standard machine learning data set for this problem, and you'll get that response. But Kaggle is a good platform.
Yeah. We have one more people, Vivek. Vivek, what do you want to ask? You can ask. I hope some network glitch is there.
Yeah. Hey Vivek, can you hear us?
Yes, I can hear. Yep.
Yeah.
I just want to ask one question, that as you said that Python, most of the people are skipping these days in the market, but as we are growing apart from this after graduation, and we all heard about that a few other language like .NET, C# and Python grooming in industry, like for the MI and AI. Means there are some drawbacks for the Python, or as a fresher, like we should attempt to Python or some the language which is more compatible.
Yeah. No. You should stick to Python. I'll reiterate myself what I said. So it's not most of the people. It's very few of the people who. So I'll give you exactly why I started learning Swift. It's a very good question, I'll say. So first of all, Python is the standard. It's good or bad, doesn't matter. Right now, Python has become a standard for doing data science and machine learning. Why? Because it has really good libraries and ecosystem. So people are developing it. Doesn't mean that it's good. It's same thing goes for, like, let's give an example of JavaScript. JavaScript is like undisputed king when it comes to web development. There is no other language people are using extensively like JavaScript to do web development, right?
Right.
Whether it's good or bad doesn't matter, because it's used in such a big scale that people are going to use it. Same goes for Python. Whether it's going to be used or not in future, I can't predict, but I can smell a bit, like, okay, because Python has a lot of problems, so maybe Python, it's not hidden from everyone, like how slow Python language is. If you run a loop for like really long time. It's like 10,000 times from C++ or C#, as you said. These languages are really fast, but it has become very popular right now. So there is no particular language which I see right now which will take over Python in data science. But there are some new projects coming in, especially in Julia and Swift. Because why I'm stressing on Swift is there's a thing called TensorFlow for Swift. Yeah, Swift for TensorFlow, sorry. So Swift was always an Apple designed app, always have been. So all the iOS, all the iPhone apps and the Mac apps were written in Swift. It's a really good language, but now Google is jumping into it, and because they saw it, so they created this platform. So this is very new right now. It's very early phase, but they are jumping into it, and they are thinking, okay, let's try something else which is not Python and works really well. So they are trying, and some of the guy who actually designed the compiler for Swift, LLVM compilers, is one of the basic fundamentals of best compilers right now. It's like industry standard for compilers right now. He has also jumped into this platform to design Swift for TensorFlow. So I'm seeing some people, some really smart people jumping into Swift right now. Therefore, I thought like, okay, I'll give it a try as well. And I'm starting as well. So I don't know whether it will hold or not, just as a side project. But if you're starting fresh, stick to Python. Once you have learned some good stuff in Python and like you have some basic knowledge, then I'll say like try some other language. But Python is the go-to language in data science right now.
Yeah, makes sense. Yeah, as for the beginners, we will learn about the algorithms and like Python.
Yeah.
Makes sense. Thank you.
Cheers. All right. Any other questions, sir?
Vishal, we have the last question, that where and how we can begin for the machine learning. Could you please explain the career path in short? This is one of the students from batch 2022.
All right. It's same as Jitin asked and other people ask. It's just simply really quickly just start, just finish 1 or 2 month introduction so that you have like slight idea what machine learning is doing, because this 1 hour session can't do justice to it. Just see or go on popular courses and see which course finishes in 3-4 weeks and start a project. This is always, I believe it's rule number 1, learn by doing. So start a project, your personal project, could be anything, solving your neighbor's problem, society problem to a bigger problem, but start a machine learning project, try to solve it and make a Git repo, show it in your resume, and this will give you a kickstart in your career. And then when you go to starter's job, some companies do hire interns and graduates for machine learning things, and then you will have something to show in your resume and you can answer questions in your interview. So I'll always recommend doing a project. Maybe a final year project. Yeah, if your batch is 2022, you can start now, but in 2 years you can actually build something really cool.
Okay. Do we have some question from Vibhor?
Vishal, I have a question. Vishal, I have a question for you.
Yeah.
When it comes to like Twitter or Instagram and all these platforms where it's all about followers and people following you. So what kind of and what format or technique should one use to increase that in terms of that your followers are increased?
In terms of machine learning?
Yeah, in terms of machine learning, because I think Twitter analytics or the Instagram
no, I get your point. But it's more than data science. It's not just the data science. A lot of it comes from the strategy of the people who actually design how they're going to sell their platform. It depends upon what platform. If you are on Twitter, I'm not expert on increasing your followers.
No, but you must be aware of how does this Twitter analytics or how does they work? What are what program do they use when it comes to them?
I don't know for increasing followers. Like you can use Twitter analytics to do. Let me give you an example. Right? Okay. So I have this blog. I write my blogs on this website, and I can actually see all the analytics for, let's say, let's go on the stats, and let's see in last 2 months. Well, so this is how many users who have been reading my blog. So yesterday I posted a blog. I can see lot of the people from India, a lot of people from United Kingdom, China. So I can go on months, let's say June. Yeah. And now I can target and also I can see like so people were really interested in this blog because most of the views came in June month, came on this blog. So I'll go onto this blog and see like, you can go into analytics and then I can target what if this is my agenda, like to increase my followers, then I can target like the audience. So I say like most of them are Indian, United Kingdom, United States, Singapore. These were in June, these were the people who saw my blogs throughout the world. And what kind of blogs they saw. So you can make a strategy around it. So it doesn't necessarily have to be machine learning, but it sounds like a really good project idea, to be honest. Just make a machine learning project which goes through your analytics and predict what things from your.
That's what I'm talking about. Yeah. Can you work around machine learning for it?
You can because there's a lot of text here. There's a lot of data. Wherever there is data, you can use machine learning, and this sounds like a good project idea. So anyone who's listening this, I'm sharing your idea loud right now. But if anyone wants a new idea, machine learning idea, sounds like a good idea. Go on your analytics section on Twitter, blog, whatever you use, WordPress, and just use machine learning to predict what next blog you should write about.
Thank you, Vishal. Very good.
No worries. Cheers.
Now I would like to call upon Tripathi sir to give a vote of thanks to the speaker. Am I audible, sir? Tripathi sir?
I think Tripathi sir is out.
There's some.
Yeah.
I think there is some technical glitch there.
No worries.
So, Vishwas sir?
Yes.
I request you to give a vote of thanks.
Yeah. Thank you, Vishal. I am Vishwas. I head the brand of the MIT group currently.
Nice to meet you, sir.
It was quite evident from Vishal ki Leila that you are a very huge fan following already.
Yeah, I saw that too.
So nothing to take away from that. You already have such a fan following, and I'm very sure after this wonderful session and such enlightening session, that your fan following will go more. And next time when you come here, you'll have 5-6 Vishal ki Leilas more.
I'm looking forward to that.
Audience. But my congratulations and my best wishes. You have done very well for you. I'm unfortunate that I joined MIT at a time when you were already passed out, so I missed out on the opportunity of meeting you in person. But it gives me immense pride for the fact that somebody from MIT has gone out in the world and proved his mettle. And today, a lot of your juniors can look up to you and take you as an example and bring about change in their approach. So
that's really kind of you, sir.
Before signing off, I just want you people always talk about what you should do, what you should do, what you should do. Before signing off, can you tell your juniors what to not do?
Well, first of all, thank you for your kind words, sir. And I usually come to MIT whenever I'm in India. I do come to meet Amol sir and some Tripathi sir. So I'll when I come next, I'll meet you. Don't worry about that. Not to do. Well, it's hard. It's a very hard question because it sounds really negative in the sense that I'm restricting someone, because the only advice when I was teaching in MIT and I formed a club, I'll usually recommend. I can tell like what exactly you can do to develop your interest in certain fields, like because it has to come like both from student and from the university. But the thing is, people have to discuss more ideas than just concepts on the paper. I developed my interest because when I was in the third year, I had a friend called Vineet. He wasn't good at like in writing. Sorry, he didn't ever get he couldn't pass his semester exams, but he was really good programmer. And And I used to spend time with him, knowing that I can learn a lot from him. He's doing really good right now as well. He's working in Gurgaon for a Nagaro. But it was he never seemed like a guy who can pass an exam. But he had this talent, so you can actually find these people. And then what we decided, as I said, like, do projects. When you start doing projects, you start to see that whatever you are learning right now has some implication in the real world. What you can use it in the real world, you can solve problems. So what we started doing a website where where teachers can share assignments and students can give the assignments back. And we were quite optimistic about it, although it never went anywhere. But we were like, oh, we'll pitch it to investors, we'll get money, we'll be like Mark Zuckerberg one day. We had like our dreams like that, and because we're quite amateur at that time. But still, it's good to do projects and have ideas, discuss with their friends, and although it might sound foolish and funny to your friends, and they might make joke of you, but they do know that it does help a lot in understanding what we are doing. And if you really want to do something else, I'll say, like, don't pursue BTech. It's not a hard and fast. Do something else.
Very, very true. And how much, Vishal, when you were actually in the job, when you were actually in the big bad world of corporate, how much unlearning was there? That because we do a lot of unnecessary curriculum, which is actually not required when we are in the job. So how much unlearning was there when it comes to your approach?
True. So I, like all jobs, after one point, it's become repetitive because, and also it depends upon what business requirement there are in the business. So as I said, like, I used to do data science, and a recent requirement came from the job, and they were like, we really need to make this new platform for customers. And so they put me into web dev. So in this, you can get a little tangled and just lose your focus and go away from the main target you want to build your career on. But it's quite high, to be honest, unless you're working for a startup, because there you do a lot of stuff. So again, it comes down to do your own project. So I personally take out some time. Take out some time. Hello, Vivek.
No, you can carry on.
Yes, I am there.
Yeah. So just take out some time and read and study by yourself.
Yeah, got it. Okay. I will.
Thank you, Vishal. Thank you,
no
Vishal.
worries. Thank you.
Okay.
And compliments to your accent also. You are very fluent and very comprehensible. Your language command.
मैं मेरे साथ जो रहता है वो अंग्रेजी है, तो मेरे से इंग्लिश बोली नहीं जाती थी, उसके साथ रोज सर खपा के मेरी इंग्लिश ठीक हो गई.
Compliments. You're wonderful. You're wonderful. You're outstanding.
Do we have 2 minutes more?
Someone?
Yeah. Actually, Vibhor wants to have an interaction with Vishal for 2 minutes.
Okay.
Yeah.
Vishal, Vibhor, I am allowing you to talk. Do we have Vibhor here? Vibhor?
You can pass my contact to people who want to on LinkedIn or wherever you have, so they can drop a question, or we can talk to them. No worries.
I think, Vishal, thank you very much. I'm sure you must be, in middle of something. We can see background that people are working. So.
Oh no, it's me. It's the mirror.
Okay. The mirror.
Yeah, it's the mirror.
So I take that back. Have a wonderful day. Thank you very much. You were very, very outstanding. And
no worries. Thank you.
It gives me again immense pride that you are part of our family. And
No
as you promised, I look forward to see you when you are next time in India.
Definitely.
All the best.
See you there.
Thank you.
Thank you. Cheers. Thank you for listening. Bye, guys.
Thank you, Vishal.
Bye. Cheers.